I'm meteorologist Pete Mangione. Welcome to another exciting edition of Sonoran Sky Live. Today, we will be talking about unique jobs in meteorology, and I have two special guests. The first guest will be talking about studying the biggest rainstorms on the planet, but there's a very good reason that he does that, which we'll get into in just a second. And our second guest forecasts for events like PGA, golf, things that are absolutely critical when you have thousands of people outside and you might have an approaching thunderstorm or rainstorm and a quick decision has to be made. So our first guest we will bring in, his name is Bill Capel. He is Chief Meteorologist and President of Applied Weather Associates. Thanks for joining us, Bill.
Good to be on with you guys.
All right, so full discretion, I did some part-time work with Bill many years ago, so I'm somewhat familiar with the work that Bill does. And Bill, I just told our viewers about how you study the biggest rainstorms on the planet, but you don't just do that because you're passionate about weather. There's a very specific reason that you do this, right?
Yeah, although I would. I mean, what's better for a meteorologist than getting to analyze the biggest storms that have ever occurred, right? But there is a very important and specific purpose to doing that. There's a lot of critical infrastructure around the world, like hydropower dams, nuclear facilities, mining operations, all of which actually occur in Arizona as well, that have to be designed properly and safely, and they have to be designed to handle the biggest rainfall events that could ever occur at their location and make sure that they don't fail, they don't overtop, and that people are safe. And so we work on deriving that meteorological information so engineers and hydrologists can have the data they need to properly evaluate the risk and exposure of those sites, make sure they're designed properly. And I like to call it the Goldilocks effect, because we don't want to over-design, we don't want to under-design, we want to get it just right. Because if you over-design, you're spending many millions of dollars more than you need to. If you under-design, you're at risk of property and life being lost unnecessarily. And so you want to get it just right. And so we, as a meteorologist in this field, we get to have the most fun you can imagine, analyze the biggest storms that have ever happened, give that information to engineers and hydrologists that wouldn't have it otherwise, and see them actually apply it in the real world to save lives and save money. So it's pretty awesome.
It sure is. I find this stuff absolutely fascinating, Bill. I'm going to show a map of some of the studies in parts of the country and the world that you've gone over at Applied Weather Associates. Here it is over my shoulder here. So we've got obviously these studies all over the country, different parts of the world. I'm going to focus here on Arizona because, of course, we're an Arizona station, a lot of viewers here. So I've got the graphic up, Bill. I'm going to zoom this in. Yeah. This is called transposition zones, but just in plain speak, basically what you're doing is you're saying, okay, if there's a rainstorm in one part of the state, if it's kind of in the same general area as another storm, you could sometimes say, well, even though that storm happened a few miles away, you could kind of apply it to this other area too, right?
That is absolutely correct. So Arizona is a great example. Such a diverse state with so much variance in topography and climate and elevation. And so we have to take that into account when we consider where one storm occurs and where else it could occur. And that's very important because remember, we're talking about these incredibly rare rainfall events that only happen, hopefully, almost once every 100 years or less. And so we have a very limited spatial coverage of those events. Prescott, Arizona, 1983, Roosevelt Lakes, 2014, Campo, California, 1889. And we have to say, where else could those storms have occurred versus where they were actually observed to kind of fill in those missing data? So trading time for space. And so as part of that process, we have to define regions of Arizona that have similar meteorological and topographical settings. And so really, if a storm occurred in Phoenix in like June of 1972, well, that same storm probably could have occurred in Tucson or over towards Wagon Bow. And if a storm occurred around Prescott, it probably could have occurred up around Flagstaff or over towards, Sedona and some other areas. So those transposition limits help us define areas of similar meteorological and topographical settings where we can then move storms around from one area to another.
And I'm going to pull up another graphic here. This is what you call SPAS analysis. And basically what you do is you look at storms that have actually happened. You plot out the rainfall, but sometimes this process gets complex because you've got mountains and valleys. So the specific SPAS storm is from the tropical storm Norma Remnants, and a lot of green and purple showing up. Bill, that looks like that might be rainfall. I'm going to zoom in this a little bit. That could be over, what, 5, 6, 7 inches, some of those areas?
10, 11, 12 even. Yeah.
Wow.
If you remember this storm, of course, this was one of the biggest storms to ever affect Arizona back in 1970, Workman Creek. I think it was a state rainfall record until another storm in 1997 surpassed that. And yes, it's a remnant tropical system, which occurs every once in a while in Arizona. In fact, last year in October, we had 2 back-to-back systems that produced a huge amount of rainfall in the Four Corners region. And those are exactly the type of storms that we want to analyze. And the fun thing with the SPAS process is it recreates the storm, right? How much rainfall occurred in time and in spatial patterns and in magnitude. In a place like Arizona, where topography is so important and you have many areas with lack of observational data, we have to fill in those gaps. And then we take that information to derive the data that's used for the work that we do, which again is called probable maximum precipitation, that theoretical upper limit of the most amount of rainfall that could ever occur. So a storm like Norma in 1970, for example, is one of those storms that helps produce that upper limit of rainfall, and then we can see where else it occurred. And the SPAS process tries to combine all the available data to recreate that storm, not just the point locations of rainfall observation, but what happened between those point observations. Because the chances that the highest amount of rainfall actually was observed at one of those spots is almost zero. So we have to figure out how much rain fell in between. And by the way, for your viewers or anybody who just loves weather and meteorology and wants to be part of the process, there's many volunteer programs that they can get involved with. Kokoros is a great example, where their rainfall observations in their own backyard are actually used by people like me to make these literal million and billion-dollar decisions on how to design critical infrastructure. So I would ask any of your viewers who are happy or want to be part of it, get a rain gauge, get your data out there, share it with the community, because we actually use it in my world.
And Bill, yeah, that program you're talking about is Kokoros. If you're listening right now, just Google Kokoros. I think it's Cocorahs. Just Google it, kokoros.org. You can get instructions on how to become a backyard weather spotter and help out people like us here at Arizona's Family and help out Bill with the projects that he's doing. So love that you brought up Kokoros. All right, let's move on here to, actually, I wanted to put up just some actual totals. Obviously, Bill, you're doing more complex work. You're not only finding these weather station reports, but you're filling in the gaps in between the stations. But this is an actual rainfall measurement from that storm, 11.92 inches of rain, about 30 miles north of Globe at Workman Creek. I mean, just an amazing storm there.
Yeah. Hard to imagine that amount of rain, right?
Absolutely. And then I pulled up a few more totals from that storm. Mountain Lemon, 8.74 inches. Sunflower from that storm, 8.44 inches. All right, we're going to go into one more SPAS analysis. Now, this is not one of your maps, but I just wanted to orient viewers here. This is a huge rainstorm that occurred at Roosevelt Lake. And you can see here the radar estimates. It looks like maybe amounts over 9 or 10 inches. So let's go into your report that you put out for this. So this happens in 2003, a 12-hour storm. And I mean, I'm just amazed at all the detail that you can get. I mean, I know it's a little bit hard to see the details on these colors, but for the viewers at home, when you're seeing all those purples and greens and yellows, you're basically filling in those gaps of rainfall in those mountains and valleys and some areas that do not have a weather station.
That's right. And in this case, we're lucky because it's 2003, which means we have NexRad weather radar to help fill in those gaps between observational points and give us a more accurate representation of that rainfall. And as you mentioned, I mean, this is 10, 12 inches of rainfall in 6 to 12 hours. Again, it's hard to imagine that amount of rain occurring, but like we say, if it's happened before, it can happen again. And if it happened just perfectly over your particular area of interest that contributed to your dam or your nuclear facility, can you handle that? That's the whole point, right? And Peter, I will say one really cool thing. You know, we've done the study that covers the entire state of Arizona back in 2013. We're currently updating that study right now with the Arizona Department of Water Resources and the Dam Safety Program to add even more information and add other aspects. And all those outputs that we're producing for Arizona are freely available to any of your viewers if they ever want to go and see these reports and these rainfall reconstructions and the data that's used and how it's applied. So just another fun aside that there's a lot of neat information out there after this talk if somebody ever wants to go out and look and see how this is all put together and applied.
I think there will be a lot of interest in this, Bill. All right, so now I'm going to go to I don't want to say it's the most important thing that you do, but to me, this is sort of what defines what your company does. This is called probable maximum precipitation, PMP. And before we get into all the different colors here on the map, Bill, and you could correct me if I'm explaining this wrong, this is basically saying, okay, we've studied all these different storms across the country and in Arizona based on those past storms and based on what could have happened. Some of these storms actually could have happened when there was even more moisture around. You're going to put all that together and show what's the likely biggest rainstorm that could happen.
That's exactly right. You said it exactly right. Probable maximum precipitation, or PMP, is that theoretical upper limit of the most amount of rainfall that could ever occur at a given location, at a given time of the year, over a given area size. And the map you were just showing is a representation of those final values. And again, we get those final values by analyzing storms like that 1970 storm you showed, like the Roosevelt Lake storms, and hundreds of others, and say, okay, here's how much rainfall occurred as observed. But if everything had been perfect when that storm happened, and there had been more moisture available, and Mother Nature had had even more efficiency, that rainfall could have been even higher. So instead of the 11.94 inches for Workman Creek, for example, maybe that could have been 13 or 14 inches had everything been perfect. Then we take that storm, we move it to everywhere else where it could have happened, and we say how much rainfall could have happened at that point. We do that with all the storms. The biggest of all the storms, once we put them all together, becomes that upper limit and produces like the maps that you showed, which is an upper limit of the most amount of rainfall that could occur over any location in Arizona for that particular area size and that particular duration. And then that's done for hundreds of durations and area sizes, and that becomes the input that the engineers and hydrologists use to model the runoff from those events.
All right, Bill, and just so people understand this, because to me this is just remarkable. So I'm going to zoom this in, and it might be a little bit hard to see, but I'm going to roughly put my finger, I'm not sure if we can take where my finger, there we go. I'm going to put my finger roughly where Phoenix metro area is in Maricopa County. And if I look down to the color table, this is basically saying in 6 hours, just 6 hours, the likely biggest rainstorm could potentially be 8 to 9 inches of rainfall. That's just remarkable to think about, given our desert terrain, Bill, and the tough time that some of the ground has in absorbing this water.
Yeah, well, just think about last year, last September, when you guys had 2 inches or so in just a few hours, and how much flooding and occurred, right? So now make that 6, 7, 8 inches in 2, 3, 4 hours, and think about the amount of water that would be causing problems. And if you look at that map, it shows and captures the characteristics of Arizona. I mean, the Phoenix metro area is one of the lowest spots. You go up onto the terrain in the Mogollon Rim, and you're up at 10, 12, 14, 15, 16 inches, right? And then you go up into the Four Corners, the Navajo region, and you're back down again. So we want to capture those realistic spatial variations, because it's not one size fits all for Arizona, that's for sure. And we want the PMP to capture that and be realistic as well.
All right, Bill, once again, I'm going to ask my crew if they can follow my finger here. So I'm now going to kind of point along the purplish and bluish areas, which was, you know, you referenced the Mogollon Rim up into northwestern Arizona. There we go. So here's northwestern Arizona, and then on to the parts of the Mogollon Rim where we have kind of the higher terrain. So we've got purple and blue showing up. Bill, how much rain is that in just 6 hours?
Yeah, that's 15, 16 inches of rain in just 6 hours. I mean, imagine that. It's hard. And the point is, it's hard to imagine because it is supposed to represent that theoretical upper limit. But boy, if that amount of rain fell in your watershed in 6 hours, you're going to probably have some problems. And if you have critical infrastructure that has to be able to survive that, then that's why you need that information to make sure it's designed and dams don't fail and so on. That's exactly right.
For sure. And Bill, I took some liberties with your map when I was kind of studying this yesterday, and I made this graphic here. Cool. So I know we discussed this a minute ago, so I can probably take out the word future, but I can basically just say the likely biggest 6-hour storm in a 10 square mile area near Payson, Arizona, over 16 inches in 6 hours. Again, just, you know, I study this stuff all the time, but that's tough to wrap my head around too.
Yeah, that's exactly right. It's hard to imagine. But as I said earlier, if these types of storms have happened before, you give Mother Nature enough rolls of the dice and they can happen again. And at some point, there's a possibility that it could happen over your location of interest. And that's what we have to design for those critical infrastructure. The chances of it occurring are incredibly small. I mean, the whole point of PMP is that it should represent nearly a zero probability, not zero, but close to zero. So when you think of it in terms of recurrence interval or a chance per year of occurrence, it might be 1 in a million or 1 in a billion type of recurrence interval, which is basically 0.000001% chance in any given year that it could happen. So we don't want it to happen. We don't expect it to happen. But if it ever did happen, we want to be prepared for it.
And let's see if I can go to, all right, so this is kind of the same thing we were talking about before. This is your probable maximum getting tongue-tied, precipitation. This is, instead of a 6-hour storm, this is what could happen for a 72-hour tropical storm. And of course, in Arizona, we get a lot of the remains and remnants of these tropical storms. So this kind of setup is important too, right?
That's exactly right. So again, we want to make sure that our PMP represents actual storm events that could happen for a given area. And in Arizona, we basically have 3 types of storms, right? The North American monsoon season thunderstorm events, general frontal systems, say for December, January, February, March, and then this type, which is remnant tropical systems, basically from June through October. So we want our PMP to be separated out by each storm type. The previous one you showed was for the local storm type. This is for the tropical storm type. And again, you see the importance of the topography there. And you get even higher amounts of rainfall because you're talking about 24, 48, 72-hour durations where it can rain for several days versus just say 1, 2, 3, or 4, 5 hours.
And Bill, for this map, so again, I'm seeing the purple zone here over places like the Mogollon Rim, some of Arizona's mountains. Now I'm looking at this table. Now it looks like this might be over 24, 25 inches in 72 hours. Incredible,
right? Incredible. But again, you have storms like Norma 1970, you have Octave 1983, you have I will say about, I'm sorry, I'm in Colorado, not Arizona, but Harquahala Mountain in 1997, where values were observed up in the 15, 16, 20-inch range over 2 days. And so those are the kind of events that are used for this type of PMP development for the tropical storm type. It's very rare, but it can happen.
Bill, I could talk about this stuff for days and days. You're going to learn about how informal our live stream is because we have another guest lined up, but I don't want to let you go until our next guest is here. So I'm going to ask my producer, Katie. Katie, is Kyle here? Okay, so Bill, maybe you're a golfer. Our next guest is actually going to be a forecaster that does PGA events and golfing.
Hold on, no, I'm a bad golfer. So a weather problem at the PGA course would probably help me out. I'd have an excuse to get off the course, but that's a whole nother story. Okay.
Hey, Bill, thanks so much for being part of Sonoran Sky Live, and I hope you work on your golf game. But hey, this has been fascinating. I think our viewers are going to be very interested in this.
Thanks, Peter. And you guys do great. Appreciate it.
All right, have a great day.
Okay.
All right, so that was a look at, tracking the biggest rainstorms and just fascinating stuff. Now, we are going to take a maybe 30-second or minute break before we bring on our next guest, but why not go into the forecast that we're looking at if you have any questions about that. And hey, we've got 70s moving in this week. It gets even warmer by the end of the week. Arizona is an interesting place because I do know some people that complain when we get these morning temperatures down into the 40s. If you don't like that, actually, you could see we may have some 50s arriving for morning temperatures by the middle to the end of the week. Now, obviously, that's a temperature for Phoenix Metro. You get outside of Phoenix Metro in some of the more rural spots, and you can easily still see 40s. But even our mornings will start to get a little milder as our 70s, you can see, what's the warmest here? 78. So when you see a 78 here in the 7-day forecast, it's not completely out of the question that you can get an 80-degree temperature somewhere. So obviously the mild trend continues here in Phoenix, Arizona. I'm not sure if we can go back to the touch screen. Yes, we can. I love hearing that answer. So we're going to jump back to the touch screen and just review what we were just talking about. So again, we just had Bill Capel on, who does these studies of showing us what is the likely biggest storm that we could see in Arizona. This particular map shows what is the biggest 72-hour storm that we'd see. And again, this purple zone is over around 24, maybe 22 inches of rain. So just fascinating to see that. Okay, we have our next guest on. I want to bring in Kyle. And Kyle, I apologize. Is it Kyle Koval? Kyle Koval? I was kind of going through both pronunciations in my head.
Yeah, no worries. It is Koval.
Koval. Okay. That was basically my second guess. Well, Kyle, thanks so much for joining us. Kyle, a meteorologist at DTN. You do a lot of forecasting, a lot of weather risk analysis, and I hear that sometimes you do some forecasting for big-time golf events.
Yeah, that's correct. Pretty much my full-time job here is to travel with the PGA Tour as our on-site meteorologist. Travel to about, as you can imagine, quite a bit of variety occurs as I go to destination, but really pretty much fully integrated with the PGA Tour as the on-site meteorologist.
And, you know, to me, Kyle, this sounds like such a high-pressure job. Is it difficult to make a call when maybe 24 hours in advance you see that there might be a risk of lightning at one of these PGA Tour events, and you have to make the call, okay, should this get pushed somewhere, you know, postpone, or should we still risk it? Or is that not actually your call? Do you just give them the forecast and then you have other people that actually make that decision whether to cancel or postpone or not?
Yeah, so we go through a pretty deliberate process. There's a lot of components involved with these decisions, and really we try to set a threshold so we can kind of take the irrational thoughts that go through our minds as we make these decisions. So, you know, for set a threshold around like 70% chance for lightning for the next day. And if we breach that threshold in the forecast, okay, we'll make the decision that we should probably move tee times or make adjustments to when we start play to avoid a situation where we deal with thunderstorms. So it's kind of the thought process that goes into the decision making, but there's numerous parties involved, and I'm just one of the voices included in that conversation.
So obviously for, you know, things like golf, thunder and lightning are big threats. Is there any other kind of weather that can give you headaches when you're trying to do these forecasts?
Yeah, so obviously you hit the nail on the head there with lightning as being kind of our main concern. But with golf, there are several weather factors that are kind of influence the game or really the setup of a golf course. So, you know, wind is a huge factor, influences the golf shot in ways that maybe some people wouldn't really realize. But the direction and velocity of the wind will have a big influence on where the holes or the tees are set on the golf course. And then also from a moisture standpoint, just from a golf course, the grass and really the grass is highly influenced by the moisture that's occurring throughout the week. So there's a lot of factors or a lot of parameters that we're looking at throughout the week, not just lightning. And so even on maybe what would be considered a quieter day of weather, there's still questions being asked regarding temperature or moisture and whatnot.
And I believe, have you forecasted for the Waste Management Phoenix Open before?
I have, and I'm kind of have I was there 2 years ago and probably might not be invited back given the weather that we experienced that week. So kind of on the blacklist for the time being, but hopefully I am invited back here within the next couple of years because I enjoyed the tournament immensely.
Oh, so that was so I was not here 2 years ago, but I've heard stories that was the rain day, right? I think I'm understating that.
It sure was. Yes, I think I want to say we had about 2 inches of rain that week, and numerous days where rain fell. And I think the cherry on top there was we had a couple mornings with frost. And nicer days, we still ended up with weather delays because of the frost.
Wow. What other PGA events or other golf events have you done that kind of stick out in your mind? Not necessarily bad memories, but good memories.
Yeah, you know, I think it's always, at least from a good memory standpoint, it's always nice to make good calls, make a good forecast in advance where you change the tee times or you change just the TV times to hit the window. Those are probably the good calls. I think obviously the bad calls linger in your mind a little bit more than the good calls, so you're always looking to improve based on the decisions that have been made in the past and really just improve as a forecaster going forward.
Do you have deadlines? I mean, are you ever involved in a thing where, they say, hey, we need to know what the decision is 24 hours in advance. So you have to finish your forecast one day before so we can make preparations to either allow people to attend or tell people that the event is postponed?
Yeah, I would say by the end of the day is really our deadline here, or the end of the previous round is usually our deadline to make some of these more critical decisions. Again, everything's pretty fluid on a week-to-week basis. So based on the potential weather that is threatening us, the timeline for those decisions will fluctuate. Obviously, anything regarding tee times or moving up play, those decisions will be made usually 24 hours in advance. Sometimes we might make more minor decisions the day of or the morning of, and those might be more related to the golf course setup. So really, it just depends more so on, influential the impacts would be, and that will dictate the timing of any of these decisions.
Kyle, are you yourself a golfer, and do you ever forecast for your own golfing outings with your buddies?
Unfortunately, I really am not a golfer. I love the game itself, but you do not want to catch me on a golf course. It wouldn't be a pretty sight.
Well, that means you waste a lot less time than I do. So, Kyle, that might be a good thing. Are there any unusual things that you have to forecast for that people might not think about? Have you ever had a situation where it might get too hot and you're worried about heat being a factor out there?
Yeah, definitely. Actually, temperature in itself is probably not something that might come to mind for most people. Obviously, high heat can be dangerous, and we try to make precautions once we know ahead of time if it's going to be a hot week. Obviously, the tournament will make precautionary measures there to provide enough water and cooling ahead of time. And then really from the opposite side of the spectrum, you have cold temperatures, which can produce frost. Obviously, Phoenix is well versed in the frost during the winter, which for a golf course, you cannot play on an icy golf course, potentially damaging the grass. So either temperatures, either side of the temperature spectrum, it can be influential on a tournament. And then trying to think here, something along the lines of fog, visibility. Is if you cannot see several yards down the golf course, you will not be able to play. So this kind of a few other weather influences that could impact us throughout the week.
Kyle, that's interesting. I did not even think about fog. I mean, golf to me is hard enough when I can see perfectly, let alone having fog in the way and not being able to see anything. Have you ever had to forecast when there might be a potential of like a severe weather outbreak, severe thunderstorms or tornado, something like that?
So I think the best comparison I can make is more so tropical related. My first tournament that I ever did was affected by a landfalling hurricane, or nearly a landfalling hurricane in Florida. We actually had to completely cancel all 4 rounds of the tournament given the impacts of that potential system. Fortunately, it did stay offshore, but the golf course received over 10 inches of rain that week. I think it was the right decision to cancel that event. Thankfully, have avoided the worst from a severe weather standpoint, at least from a damaging wind or a tornado standpoint. But I think all of us that work on site have our own unique weather stories that we've experienced throughout the way. Always fun to kind of tell these stories to people and provide these details.
Absolutely, Kyle. Well, hey, I want to thank you for giving us a few minutes of your time today. I know that your job can be a little crazy if impactful weather is hitting. So thanks for taking a few minutes to explain what you do and talk about weather and golf and all kinds of cool stuff like that.
Yeah, thanks a lot. This was a joy. Hope everybody enjoyed it.
All right, Kyle, have a great day. Thanks for being on the show.
Thank you.
All right, that is going to do it for this episode of Sonoran Sky Live. We gave you a guy that tracks the biggest rainstorms on the planet, and then we gave you a guy that tracks weather for golf events. 2 very unique jobs in meteorology. We will see you next time on Sonoran Sky Live.